You are watching video on SEE Class 10 Subject Science. In this video series, we are going to study chapters of Physics, Chemistry, Biology, Astronomy and Geology. Now this part deals with Physics chapter 4, and in this part we are going to do solution of numerical problems, and this is part 2. Now we are in question number 3. Calculate the force of attraction between two bodies with their mass is 100 kg each and they are 1 meter apart on the surface of the earth. Will the force of attraction be different if the same bodies are taken on the moon, their separation remaining constant? Here are two parts of the question. In the first part here, calculate the force between two bodies, and next part says, will the force of attraction be different? Will this force be different if you take it to the moon? So you have to write the answer. So the first part of the question, you are going to calculate force. So we'll write solution on top and you'll write given information in the question. From the question, M1 mass of the first body be 100 kg, M2 mass of the second body be 100 kg because 100 kg each, and distance between them is 1 meter. Then you have to calculate force. Okay, now here you need universal gravitational constant, that is G, and its value is this. Okay, now you'll use the formula which is most appropriate for calculating force, and it is this formula from Newton's gravitational law. Okay, so F equal to G m1 m2 divided by d square. So here we'll substitute the values in this formula. So G is 6.67 into 10 to the power minus 11, m1 is 100 and m2 is also 100. Okay, now divided by d square, d is 1 meter square. Now again rearranging the equation, now you are going to do calculation, and before calculation you have to do the rearranging. 6.67 into 100 into 100, okay, into 10 to the power minus 11. So the number with power should be written at the end. Okay, now let's deal with the number which do not have power, 1 square. Now over here 6.67 and 100 into 100, you can write it as 10 to the power 4 into 10 to the power minus 11. From here 100 into 100, 10 to the power 4, and divided by 1 square means 1, and from here again F equal to, now 6.67 into 10 to the power 4 minus 11, 10 to the power 4 minus 11. So how much you get over here is or F equal to 6.67 into 10 to the power minus 7 Newton. So this is your answer. The force between two bodies with 100 kg mass each is 6.67 into 10 to the power minus 7 Newton. Okay, now in this calculation what did you do? You rearrange the numbers without power in front. Then you have written the numbers with power at the end. Okay, so this way you can be careful in calculation. Okay, there are least chances of making mistakes. So this is your answer. Force of attraction between two bodies is 6.67 into 10 to the power minus 7 Newton. Okay, now first part of the question is done. Now the second part says, will the force of attraction be different if the same bodies are taken to the moon? The force of attraction will remain same if they are taken to the moon. Okay, their separation remaining constant. This force will not change if you take these two bodies to the moon, keeping them 1 meter apart. So this is question number 3. Now we'll see question number 4. Question number 4 is, okay, question number 4 is this one. The acceleration due to gravity at the surface of the moon is 1.67 meters square, 6 meters square, 1.6 meters square. If the radius of the moon is 1.7 into 10 to the power 6 meter, calculate the mass of the moon. So you are going to calculate mass capital M of the moon. So you'll write down solution on top and given informations given in the question. So small g is given on the moon, acceleration due to gravity on the moon 1.6 meter per second square, radius of the moon 1.7 into 10 to the power 6 meter. So you are going to calculate mass, capital M, which is mass. Okay, mass of the moon. Then you need this universal gravitational constant g equal to, this is the value. Okay, now we'll use the formula which is most appropriate, suitable for finding mass of the moon by using this data. Small g equal to gm divided by r square. This is the formula for acceleration due to gravity. Now we'll rearrange the equation in this manner. G cross multiplication, gm comes to left side and g into r square, these two go to right hand side. Okay, this is in left hand side. Now you are going to calculate capital M. Let the capital M be alone this side because you are going to calculate it, divided by g. Now rearranging the now substituting values. Small g is 1.6. Small g is 1.6. Okay, now we'll do this way. Small g 1.6 into r square 1.7 into 10 to the power 6, 10 to the power 6 whole square. Okay, divided by g is 6.67 into 10 to the power minus 11. Now we'll do further calculation there. 1.6 into 1.7 into 1.7 because it is a square. Okay, now into 10 to the power 6 into 10 to the power 6 because this is also a square. Okay, you can write it this way, and 6.67 into 10 to the power minus 11. Now let's do the calculation. 1.6 into 1.7 into 1.7, multiplying these three, 1 2 3, how much you get is 4.624. 4.624 divided by 6.67, this one 6.67 into, now let's deal with the power. 10 to the power 6 into 10 to the power 6 is 10 to the power 12. Okay, and 10 to the power minus 11 goes to numerator, it becomes into 10 to the power plus 11, or you can write it directly also. Okay, this way also, 10 to the power 12 plus 11, you can write directly also. So m is equal to, now this the 4.624 is divided by 6.67, how much you get? 0.693 into 10 to the power 12 plus 11, 23, 10 to the power 23. Okay, now here from the law of indices, m equal to, there should be one digit, after decimal, 6 point before decimal, 6.93 into 10 to the power minus 1, because if you make the digit move towards right, then minus power will be added, 10 to the power minus 1 into 10 to the power 23. Okay, now you see, then your answer is going to be 6.m equal to 6.93 into 10 to the power minus 1, 10 to the power 23. 23 minus 1 becomes 22. Okay, now so this much kg. Okay, this is this much kg. So mass of the moon is, therefore mass of the moon is 6.93 into 10 to the power 22 kg. This is the solution of question number 4. Now from question number 4 you can do solution this way also. Instead of finding mass, the question is to calculate acceleration due to gravity. In the same question, calculate acceleration due to gravity of the moon if its mass is 6.93 into 10 to the power 22 kg. If you put the same value of mass of the moon and radius same as in the previous question, then will you get acceleration due to gravity 1.6? Let's check it. Okay, now the same question has been written this way, and in this question, instead of mass, you are going to calculate acceleration due to gravity. So let's write down the solution on top. Then given information in the question, mass of the moon this much, 6.93 into 10 to the power 22 kg. Okay, this is the data which we found in the previous question. Now radius of the moon 1.7 into 10 to the power 6 meter. It is same as before, and you are going to calculate acceleration due to gravity, small g here. So value of universal gravitational constant same. Now we'll put the values in this formula. G equal to G is 6.67 into 10 to the power minus 11, and capital M 6.93 into 10 to the power 22. Okay, now radius is 1.7 into 10 to the power 6 whole square. Yes, now G equal to, now we'll do the calculation here. Let's rearrange the numbers. 6.67 into 6.93. This, the numbers without power, put them together, and numbers with power will come towards the end. Okay, you are regrouping this number for calculation. Divided by 1.7 into 1.7, because this is a square, and 10 to the power 6 into 10 to the power 6, because this is also a square. Okay, now let's go to the next step, or G equal to multiplying 6.67 into 6.93. How much you get is 46.22, multiplying this and this. Okay, into 10 to the power minus 11 into 10 to the power 22. So 22 minus 11 becomes, this is 11, and the sign is plus because 22 has sign plus. Okay, now 1.7 into 1.7, 2.89 into 10 to the power 6 plus 6, 12. Okay, now further calculation. G equal to, now 46.22 divided by 2.89. How much you get is 15.99. Okay, into 10 to the power 11. Now this 12 comes to numerator, it becomes minus 11 minus 12. Okay, now G equal to, small g equal to, now 15.99 into 10 to the power minus 1. Okay, now or G equal to, now from law of indices you see there should be one digit after decimal, 1.599 into 10 to the power, if you shift the decimal towards left, then plus power will be added. So 1, because you shifted one position, so 10 to the power 1 into 10 to the power minus 1. Okay, now the next step, G equal to 1.599 into 10 to the power plus 1 minus 1 means 10 to the power 0. Now small g equal to 1.599 into 10 to the power 0 means this is 1. Okay, G equal to 1.599, this much. Okay, meter per second square. Now G equal to 1.599 means it is almost 1.6, approximately this one. Okay, meter per second square. Therefore what you have calculated here is acceleration due to gravity on the surface of the moon is 1.6 meter, same as before, meter per second square. So we have found the value. Okay, now this is the solution. Now this is the question similar to the one which we did before. The mass of the heavenly body is 1/3 of the mass of the earth, and its radius is just half of the radius of the earth. If a stone weighs 200 Newton on the earth's surface, find its weight on the heavenly body. The similar type of question was done before also. Solution, and you have to consider two cases here. One is earth and other one is heavenly body. The mass of the earth is capital M. So mass of the heavenly body 1/3m according to the question. Radius of the earth is r, and radius of heavenly body 1/2r from this question. Okay, so weight of the stone 200 Newton because question says so. Then your task is to find the weight of the stone on the heavenly body. Okay, now in the first case you have to consider F equal to gmm by r square. F can be written as weight because F equal to W. So W1, let W1 be the weight of the stone on the earth. So 200 Newton as question has given here. Okay, and let W2 be the weight of the stone on the heavenly body. W2. Okay, so W2 is equal to gmm by r square, but over here stone is, mass of the stone is 1/3. Mass of the heavenly body, mass of the heavenly body, radius of the heavenly body 1/2. So you have substituted the values. Then after calculation 1/3 divided by 1/4, 1/3 gmm by r square, 1/4 r square. Okay, because this is 1/2 r square, and W2 equal to 1/3 into, this comes to numerator 4 divided by 1 upside down. Then the remaining, this one gmm by r square. So 4/3 equal to, so gmm by r square, from here it is 200 Newton. Okay, because this one 200 Newton, right? So W2 equal to 4 into 200 divided by 3. W2 equal to 800 divided by 3 Newton. Now you do further calculation and find the weight. This is the Newton. So this way you do solution.